Hello everyone, welcome to this course of Web3 where we will be talking about Web3 security, smart contracts and different types of attack on Web3. I'm Tanya Goyal and today I will be talking about evolution of web and the basic principles of Web3. Okay, so the evolution of web is mainly divided into three parts. Web 1.0. So Web 1.0 was basically read-only content okay, and it emerged in the early days of internet when the internet was newly created. Internet, in this, website was basically static and the content was created and controlled only by the website owner, or you can say developer owner or developer. Okay, interaction between users were limited. User interaction limited, or you can say there is no user interaction. It suppose it's only limited to filling a form. So let's take an example. It's Wikipedia. The Wikipedia we all are seeing today, the Wikipedia we all are seeing today. In that Wikipedia we can write, we can also change the content of it, है ना? like uh, you can you can change the content, and the developer of Wikipedia or the anyone on the backend can review the content, and if there is some mistake in the content, they will simply revert back to the original content. Okay, but in early days you can there was no such thing. You can only read the content and there is no user interaction. So it created a problem for everyone. For this problem, Web 2.0 came as a solution. Web 2.0. Okay, there was a major shift towards a interactive, interactive, and user-centered web experience. The current form of internet which we all are experiencing today is 2.0. Web 2.0. There is active participation, user interaction, and collaboration among everyone. And unlike unlike Web 1.0, where only a developer can post content, Web 2.0 brings a revolutionary change where everyone can become a creator. Okay, let's take an example of YouTube. Suppose this is YouTube. Everyone can post their own content. Everyone can post their content and earn the money from it. है ना? And there is also user interaction, like you can comment on someone's video, or you can like their video. So am I right now? So now you must be thinking, if Web 2.0 is so great, why is there a need for Web 3.0? Let me give you an example. Have you ever noticed that if you search something on internet, suppose this is you, okay, you have searched something on internet, okay, you have searched something on the internet. For example, let's say you have searched for earphones. Okay, you have searched for earphones. So after some time you start getting advertisement related to that product from everywhere. If you open your Facebook or Instagram, you can see the advertisement of earphones pop up on your social media. Okay, so Web 2.0 collects all your data and sell it to the advertisement company to and this arises a big problem. Okay, Web 2.0 arises a big privacy question. you can say no privacy. Okay. To solve this problem, Web 3.0 came. So now Web 3.0 came into the existence. Decentralized. It is decentralized web, basically based on blockchain technology. We will talk about blockchain in our next video, but let me give an idea about it. Blockchain is decentralized. Decentralized means you can see your data is stored on these nodes rather than a single point. Okay? Unlike Web 2.0, where all your data is stored in only this place, now all your data is stored in different nodes. So it is decentralized distributed ledger technology that records transaction across a network of computers in a secure and transparent manner. Okay? Let me give an example. If you made an like suppose this is you, this is your friend, you both have made a transaction, suppose of 2 bitcoins. Okay? 2 bitcoins to your friend. So all these transaction information will stored in this block. Okay, and in this block, if someone has made another transaction, it will be stored in this block, and another transaction in this block. So it created a kind of chain. Now it created a kind of chain. It created a chain of blocks. So this is what we call a blockchain. We will talk about this later. Now let's come to Web3. It is decentralized, secure, and user centric. The core of Web3s are decentralization. I have already explained it to you what is decentralization. Web 3.0, it is decentralized. Okay. Rather than a single point, it stores data on different nodes. It provides security. It ensures that users have more control over their data and digital identity. It will enable user to only disclose the information which they really want. Okay, unlike Web 2.0 where you need to accept the cookies to view the data, in Web 3.0 no need to accept the cookie, or any type of terms and condition except cookies. Okay. So it's also transparent. It's provide transparency. Transparency. Web 3.0 will enable transparent and auditable transaction, which allow users to verify the integrity and authenticity of data without relying on centralized authorities. Okay, we will talk about all these things later. So it sounds cool, right? It is decentralized, secure, it provides security, no need to accept the cookies, and it is transparent. So that's it for this lecture. See you all in the next lecture. Thank you. So hello everyone. Welcome back to this lecture where we are going to talk about the Web3 architecture. So first of all, before starting the Web3 architecture, let's see the Web2 architecture for better understanding. Okay. So let's take an example. This is you. Let me write this. This is you. Okay. So we have a front end. This is the front end, which is made up of HTML, CSS, and JavaScript. Okay. So basically, it's the UI of a website. This is front end. Okay. Which talks to the backend. This is your backend. This is backend. So backend have applications business logic, like what happens when a user sign up on the website or edit something, etc., etc. Okay, and all the data. This is and all the data of applications such as users, their data, everything is stored on the database. Database. Okay, you interact with a front end interact with a back end, and backend will interact with the database. So this is the whole Web2 architecture. All this code is hosted on a centralized host, but for Web3, it's not that simple. There is no centralized database that stores the application state. Instead, we use blockchain technology to store the data. Okay, I have given you a brief about blockchain technology, like what is blockchain technology in the previous video. So now let's see the Web3 architecture. So just like Web2, Web2, this is you, and we have a front end here. Okay, so without front end, how will you interact with? So front end is necessary. This is front end. This is your back end. This is front end and back end. But instead of connecting it to a database like we have did it in Web2, see this, we have connected it to a database now, but instead of connecting it to a database, we will use a blockchain technology. So this is let's take an example. We have only 3 nodes in this blockchain. Okay, we have only 3 nodes. Okay, let me just let me cut it. Okay, so we have only 3 nodes and they all are interconnected. This is your blockchain technology. Okay, blockchain network. So to and backend cannot interact directly with blockchain network. Okay, for this we need a node server. This is a node server. We are going to connect it with a node server. So there are many third parties like Infura, or let me recall the name. Infura, and there was one more. Yeah, Quicknode. Okay, so there are third parties, Infura and Quicknode, which provide API with which we can connect our this backend with our blockchain technology. Okay, now what happens within our blockchain network? Okay, so this is inside our blockchain network. What happens inside it? Okay, let's see. So we have something called Ethereum virtual machine. We have inside it, we have a Ethereum virtual machine. It's called EVM. EVM. So Ethereum is similar to Bitcoin, and EVM is used to execute the logic behind the smart contracts. Now you will say, what is smart contract? Okay. So smart contracts are the business logic and written in Solidity language. We will talk more about smart contracts in the next videos. But for this, just understand they are a con- smart contract. Okay, so for this video, just understand these are the business logic and written in the Solidity language. Okay, and underneath the EVM, we have our whole blockchain. Okay, so this is our whole blockchain network. They are connected. So these blocks can be storing any piece of information such as transaction or any metadata. Okay, so let's understand it again. This is you. This is you. Okay, wait. Oh no, what is this? I mean, leave it. Okay. So this is you. You have interacted with front end and front end interacted with back end. But instead of a database, we have a blockchain network. This blockchain network and backend and blockchain network cannot be interacted directly. We need a node server with which backend will connect with a node server and node server will connect it to blockchain network. Okay, and inside the blockchain network we have a EVM, Ethereum virtual machine, which is used to execute the smart contracts, and smart contracts are the business logic of an application. And underneath the EVM we have our whole blockchain. Okay, so in case you are trying to read some data from the blockchain, this architecture is enough. Okay, but what if you are trying to write some data? For this you need to have a private key with which you can encrypt your application. Okay, for for writing the data you need to have a private key. For this, MetaMask is used. MetaMask stores a user's private key in the browser, and whenever a front end needs the user to sign a application, it calls some MetaMask. Okay, so here MetaMask will be used. Okay, so but we do have a database in this architecture to which is used to store user specific information or some metadata specific to user. Okay, we do have a database. This is a database, but most of the transaction, most not most, all the transaction information will be stored in a blockchain network, and all the users metadata will be stored in a database. Okay, so this is the whole web3 architecture. So now let's see the clear picture of this architecture. Okay, so this is you. Okay, you have interacted with the front end, back end. This is web server means backend. Okay, and the backend is connected to a node server, and node server is connected to a blockchain technology. Okay, see, I have told you now we cannot connect blockchain directly to our backend. We need a provider which is node server, and in this blockchain technology, we have EVM, smart contracts, and Ethereum blockchain. Okay, and for writing a data, we are using MetaMask. Uh, See, this is a signer private key which will write the data in the backend. And for the database, we have used IPFS Swarm. This is a decentralized database because the whole idea of this Web3 is to make it a decentralized, है ना? So we have used a decentralized database. Okay, so that's it for today. Thank you for watching. So hello everyone. In this lecture we are going to talk about DeFi. So before talking about DeFi, let's first understand what are the traditional methods. Okay, what are the traditional methods of lending and borrowing money? Suppose this is you, you have some amount of money and you want to get some interest from that money. So you go to a bank, this is bank, okay? You go to a bank and give all your money to that bank to earn some interest. Okay. Now someone needs some loan. Okay, let's say this person needs some loan from the bank. So now bank will give your money as a loan to person B, okay, and charge some interest from that person. And when the person B will pay the interest, the bank will give some amount of that interest to you. Okay, so that's how the traditional methods work. This is you give your money to bank will give your money to person B to earn some as a loan, and the person B will pay an interest as a pay an interest, and the some amount of interest will be paid by you from the bank. Okay, this is person B. So that's how traditional method works. But in DeFi, there is no need of central authority such as bank. It is completely decentralized. This is why we called it as decentralized finance or DeFi. Okay? DeFi. So how this DeFi works? So let's see how this actually works. Okay. So suppose this is person A. Person A wants to earn some passive income by lending their assets. Assets means any money, cryptocurrency, anything. Okay. So the application we use to do all these things are called DApps. DApps. Okay. DApps means decentralized app, which will help us to provide like an interface to use DeFi. Okay. So person A interact with DeFi through DApps and deposit their assets to the DeFi. Okay. Now this is where smart contracts come. So let's say this is smart contract. Okay. And this is person A. Person A will interact with DeFi through DApps, smart contract. Okay. So this when the person A will deposit their assets in DeFi, it will trigger an smart contract. So smart contract will have some code written in it with the terms of agreement, and as soon as person A deposit the amount, smart contract will record person A deposit and update the balance. Okay. So now say this is person B. Person B. Person B needs a loan from DeFi. So the person B will deposit some crypto as a collateral. Now it will trigger again the smart contract on the blockchain, and upon approval, person A will receive the person A assets, and the collateral will be logged in the smart contract as a security of loan. Okay, so person A deposits some of their assets in DeFi, and person B who needs a loan will borrow the assets of person A and deposit some cryptocurrency as a collateral. Okay, this is what happens. It's just like a traditional method, but in this case there is no central authority. Okay, now person B will make regular interest payment based on the terms of based on the terms of the smart contract. And once person B repays all the loan, the smart contract will release his collateral. So that's how DeFi works. Okay, I hope you understand. Let's talk about DAO. Okay. Uh, DAO. DAO stands for decentralized autonomous organization. So before talking about DAO, let's first understand about the traditional organization. Traditional organization. Okay. So in traditional organization, we have hierarchical structure. On the top of the tree, we have CEO, and under CEO, we have uh, under CEO, we let's say we have a manager, manager, and manager, and under manager, we have, let me do like this only. Under manager, we have employees. Okay, we have employees. I'm just denoting employees as E. Okay, so you can understand this. We have employees. Okay. So let's say CEO made some decision regarding anything in the organization. So CEO has made some decision regarding anything in the organization. So the employee can't say no to that decision. They have to follow the decision made by the higher authority. They have their own rules and regulations and everything. So okay, employee can't say no to the decision made by their manager or the CEO. They like don't have a voting system and all. Okay, so this is what happened in the traditional organization. Now let's move to the DAO, which is the main topic of our today's lecture. DAO. DAO stand for decentralized, decentralized autonomous. I hope the spelling is right. Autonomous organization. Okay. Organization. So decentralized means that they are not controlled by any single entity or individual. Like in the above example, we have seen that CEOs, the see if CEO has made any decision, the employee can't say no to that. Okay, but in the DAO, all no single person can make a decision. Everyone will have a vote regarding a decision. Okay, they are governed by a network of participants who collectively make decision and manage the organization resources. Okay, so this is the this is the meaning of a decentralized. So let's come to the autonomous. Autonomous means they operate according to the predefined rules which is mentioned in the smart contracts. Okay, so here a smart contract is the backbone of the DAO. Smart contract. Okay, so in case if any event happens, say uh, some X event happens, so what will happen and everything is mentioned in the contract. If X happens, then what is going to happen, and if Y happens, what is going to happen. This is all defined inside a smart contract. Okay, so organization simply means an organization. So this is what is DAO, decentralized autonomous organization. Decentralized means no single person can make any decision. All the people have a vote, and if what the majority will say, that decision will be applied. Okay, autonomous means the smart contract will have all the smart contract will have all the rules and regulations, everything, And if any event happens, what will happen, if this event happen, what will happen, this is all defined in the smart contract. And organization is simply an organization. And one more thing, in traditional organization there is less transparency. Okay, let me just write inside it. No or no or less transparency, meaning what is means the information is less public, mostly they are private. But in DAOs all the information or the decision is made public. Uh, it it has transparency, is all the information and all the decision are public and transparent. And it does have no ceo ceo or high authority. Everyone is equal. And it is democratic. No single person no single person can make decision. All the people have the same, all the people sit together and made a decision. Okay, so this is what DAO means. So in this lecture we are going to talk about the NFT. NFT, it means non fungible token. Okay. So before understanding the meaning of NFT, let's first understand the meaning of difference between non fungible and fungible. So non-fungible means that each token is unique and it cannot be replicated. Okay? On the other hand, fungible means that it can be fungible means that it can be exchanged on one-to-one basis. Okay? So it means it is not unique and can be exchanged. So let's take an example of fungible. Suppose you have a note of 2000 rupees. 2000 rupees. So you can exchange this note with someone for four notes of 500 rupees. Okay, it is possible now. You can exchange your note for 500 rupees. I'm writing it as multiply 4 means four notes of 500. It does not lost its value. Right now we replicated it without losing its value. So this is fungible. But let's say someone created a song. So it cannot be exchanged, like you give me your four songs and I will give you my song. It is not interchangeable. It is unique. So it is non-fungible. Okay, let me write an example. A song. Okay. Only the creator is the owner of this song. It cannot be exchanged just like we have exchanged the note of 2000 rupees. Okay. It's example a note of 2000 rupees. So we have understood that what is non-fungible. Now let's understand the meaning of fungible. Token. So when a creator gets a token for its asset, for representing that yes, this is the original owner of this asset, and this is known as token. Okay. So let's say you have created a song, and for this song you will get a, okay, let's say it's a painting. Okay, a digital painting. And for this painting you will get a token. The token will represent that you are the real owner and no other person can replicate or steal it. In that case, NFT is used to prove that ownership of an asset. I hope it's clear. So now, where does all these things takes place? The answer is non-fungible token market, marketplace, or NFTM. Okay, this is the place where user can buy an NFT or sell it. Okay, someone can sell their NFT to the other person and transfer the ownership of their asset. So in this lecture, we are going to talk about what is Web3.js. So it is a JavaScript library which helps to connect a web application to a Ethereum blockchain network. So let's understand this with the help of a picture. This is a web application and this is your Ethereum blockchain network. Ethereum blockchain is a collection of nodes, and to use that we use web3.js. Okay, this is your web application and this is your Ethereum blockchain. And to connect a web application to an Ethereum blockchain, we use web3.js. Okay, got it? So how do we install the web3.js? So you can go to its official website web3js.readthedocs.io, and here the command is given, and pm install web3. Just paste this command into your terminal and your web3 will get installed. And here you need to provide a provider. Okay, so you can use a third-party provider like Infura, or you can create your own provider in the local host. So let's see an example of web3.js code. So this is not my code, I have taken it from internet. So here what they are doing is they have imported this web3 and use this third party provider Infura and install this and connect it with HTTP provider and installed it in web3. Okay, and so in this main function they are creating a new Ethereum account, and it will return an object containing the address and private key of the newly generated account. Okay, so this is it for web3.js. So in this lecture, we are going to study about Ether.js. So it is similar to Web3.js. It's a JavaScript library which helps to connect your web app to an Ethereum blockchain. The only difference between these two is Ether.js is more simple and secure than Web3.js. So again, you can go to its official site docs.ethers.org, and here you can get all the instruction about how to install the ether.js and everything. Okay, so use this command npm install save ethers and paste this into your terminal, and your ether.js is installed in your computer. And for importing this, you can use this command. So here I am again going to show you an example. So it's not my code, I have taken it from internet. So what they are doing is they have import the ether.js, and this they have used the third party provider Infura. And what is going on in the main function, this block number, this will return a block number from an Ethereum node. Okay, so in the terminal, when you will run this code in the terminal, you will get the block number. Okay, so that's it for ether.js. So in this lecture, we are going to talk about DLT. DLT means distributed ledger technology. We will know why this is called distributed, but let's understand what is ledger first. So ledger is a kind of record keeping system or database where all the transaction and financial related things are stored. Okay. So ledger record keeping system for financial stuff. So you must have seen that some shopkeeper have a register like this. Am I right? Where they write information such as their earning, total money their customer needs to pay, and other financial stuff. Okay, this is what we call ledger, and this is an example of paper based ledger. But nowadays, all the shopkeepers are using a centralized database. But the problem is this database that it is centralized. So let's take an example. This is a database. This is a computer, and this computer have a database of a shop. This it is have a database. Suppose if the database got hacked or there is a failure in the database, then all the information will get lost and it can't be recovered. So for this problem, DLT comes as a solution. It is a database technology that stores the data across multiple locations or participants in a network. So first of all, let me write the definition. What is DLT? It is a database technology that stores data across many locations. Okay. So let's say, let's take an example. There's a network of or computer. So every computer will have the same database or the information. Suppose this node or computer have the database such as XYZ. Okay. So this computer will also have the same data which is XYZ. This also and this also. So all the computer will have the same copy of the ledger. This is the reason why we called it as distributed. Same copy of ledger. So if there is a change in any node, then all the other nodes will get notified so that all the nodes have the same data. And the ledger is immutable. Okay. Let me write this ledger. Ledger is immutable. Immutable means once the transaction is recorded inside a ledger, we cannot change or delete it. We need to create a new transaction to update the record. Okay. So the disadvantage of this that it is very slow. DLT is very slow as compared to the centralized database. But it is more secure than that. Let me create a table for this DLT, and this is centralized database. So DLT is slow. It is fast as compared to DLT, but it is more secure. Why secure? Because it uses cryptographic security to secure the transaction. Means that data can only be decrypted by the private key, and every node have their private key. Okay. Secure means cryptographic security. Okay. In centralized database, we can say it is not that much secure. है ना? Am I right now? It can get hacked easily. The availability of DLT is more as compared to the centralized system, as in centralized system we have a single point of failure. As I have explained above, we have a single point of failure, but if there is a failure in one node, we already have the, see, if suppose this node get hacked or got failed in because of any reason. Okay, so if there is a failure in one node, we already have another node containing the same data, है ना? So the availability is more as compared to the centralized database. Why? Because it has a single point of failure. DLT is transparent as every node has the same data, so everyone can access or verify the data. Okay, so it is more transparent. Why transparent? Because everyone has have the same data, and in this case not transparent. So this is the brief of distributed ledger technology. So in this lecture, we are going to see the structure of a block and the hashing of a block. Okay, we have talked about blockchain in every video, but let's see what is inside the block of a blockchain. So I have already drawn the structure of a block. We have block number, nouns, data, ph, and hash. Okay, so the block number is the simply the number of a block. This is simple, I guess. It can be 1, 2, 3, 4, anything. Okay, so the next is nouns. Leave this thing for now. I will talk about this nouns later in this lecture. Now we have the data. We have already talked about the data in a blockchain. It can be anything, transaction history or information about node, yeah, etc, etc. Let me write this so you can write it in your note. Block number, I guess simple, it's simple. You can write number of in block. Data is transaction history or information about node, etc, etc. Okay, so now comes the ph. Leave this for now. Let's see what is hashing. So hashing is used to generate a unique identifier for a data. Okay, let me write this. Hashing generate a unique identifier. Identifier, you can take it as a token. Okay, identifier for a piece of data. Okay, so let's say we have a data and it will generate a unique fixed size hash. So let's see an example. Hash generator, let's see. We have this hash generator. Suppose I have given a data as pass at the rate 123. So what this will do, it will create a hash in MD5 or SHA-1 for our string. Okay, in blockchain we use SHA-256 for generating our hash of a block. Okay, let me write this. SHA-256 for generating our hash. So you must have understood what is hashing. It will take a data and it will generate a unique identifier of a data. Okay, So let's understood the so you must have understood what is hash. Let's see what is ph. It means previous hash. Let me write this. uh p ph. Ph means previous hash. Okay. Previous hash means it will have the hash of the previous block of an blockchain. Okay, so let's say this is a block and we have another block like this. I guess it's not getting copied. Okay, I'm not drawing the whole block here. Let's say this block have a hash something like 1 2 3 a b c c c, something like this. So in the field of previous hash, it will have 1 2 3 a b a b c c c. So it has the hash of the previous block. Okay, so now you must be thinking, what will be the previous hash of the first block of a blockchain? You know, am I right now? So the first block of a blockchain will have a previous hash at 0 0 0 0 0 0. Okay, got it? So what are the input field we are giving to so that it is generating a hash? I have already told you we will give an input, and for that input it will generate a hash value. Okay. So here block number plus nouns plus data and plus previous hash will contribute to generate a hash value. So I have already told you what is block number, what is data, what is previous hash, and what is hash. So you must be thinking now, what is nouns? So before coming to nouns, let's first understand what is mining. You must have heard this word mining before. So it is a process of verifying transaction and adding new blocks to the blockchain. Okay, mining is a process of validating transaction and adding new blocks in a blockchain, and this process is done by miners. Okay, this whole process is done by miners, and they validate transactions, create new block, and secure the network. Okay, I hope you got the meaning behind mining and miners. So suppose when you made a transaction, let me do it. Suppose you have made a transaction. Okay, you have made a transaction. It will go inside a mempool. Uh, mempool. So mempool is a place where all the pending transactions are stored. Pending means they are not yet stored in a block. So miner gathers a set of transactions from mempool and solve a mathematical problem. So first of all, you will create a transaction and it will go inside a mempool, and miners will collect all the transaction and solve a uh, mathematical problem. Okay, so they will solve a mathematical problem. So whichever miners first solve this mathematical problem, that miner will add the block in the blockchain. But before adding it to blockchain, all the miners verifies that block verifies that block, and after that block will get added. Okay, let's see this. So whichever miner first solve this mathematical problem, can add this block inside a blockchain. But before that, all miners will verify that block, and after verifying that block, it will get added to blockchain. Okay, so this is the whole process of mining. First of all, miner will collect all the pending transaction from a meme pool, and they will solve a mathematical problem. And after that, whichever miners first solve the mathematical problem, they will get to add this to a blockchain. But before that, all miners verify that block, and after that, that miner who first solved this mathematical problem will get a chance to get added to a blockchain. Okay, his block will get added to a blockchain. I hope this is clear, guys. So now let's again go to our block structure. To generate a hash, the miners get a network's difficulty target. So the target is kind of number, and whatever hash will get generate, that hash must be less than the target number. So I have already told you they have to solve a mathematical problem. So let's see what is that mathematical problem. Mathematical problem is they have to generate this hash, but to generate this hash, the network will give all the miners a target number, and that target numbers whatever hash will get generate, it should be less than the uh, target number. Okay, means target number should be greater than the generated hash. Am I clear, guys? For this lecture, just understand that target is a value and it is used to compare the hash, and it is dynamic, means it can be changed by the network. Okay, it means that target value is not fixed, it can be changed anytime by the network. So in the block structure, so in this block structure, block number will remain constant. Now we cannot change the block number. Data will also remain constant, and previous hash will also remain constant. So to generate a hash which is less than the target value, we need to adjust the nonce. So miners adjust this nonce value so that a valid hash is generated. So for example, let's say the nonce value is 1. Okay, it's not fixed yet. So a miner generated a hash from this block number nonce data previous hash, and the hash is generated, but that hash value is greater than that target number, so it will not be accepted now. So now miner will change it to 2, then check again. If it is not valid, then 3, and by brute forcing this nonce number, they will change until they will get a valid hash from that particular nonce number. So let's say the particular nonce number is 60, this is, so they will brute force this nonce number until they get a valid hash. Okay, so let's see the definition of nonce so that you can better understand this. Nonce is a random number that Bitcoin miners try to find in order to mine a new block in the Bitcoin blockchain and receive a block reward for their efforts. Okay, I have already told you it is a random number that Bitcoin miners try to find in order to mine a blockchain in the Bitcoin blockchain. Okay, so let me show you an example for this. Uh, I don't know the website. Yeah, this is the website. Okay, this is demoblockchain.org. Let's go to this blog. Okay, so let's enter some data. Let's say I have entered Tanya have done the transaction 123. Sorry, not 123. Let's say 123 only. Okay, and something light 223, something like this. Okay, now you can see the red block, you know. It means the hash is not correct. So just to see block number, this nouns, this data. Okay, now we will mine this. It's mining. Now let's see what which of these values changed. It nouns na, it was before it was something like starting from 7, but now it changed. The block number is constant, the data is constant, but to generating the hash, the nouns changed. So this is the what we call nouns. I hope you understood, guys. Now come to hashing. I have already told you it is a cryptographic process which generate a. I have written the definition of hashing here. Which generate a unique identifier for a data. So what are the key properties of hashing? Key properties. First of all, it is deterministic. Deterministic means if the input is same, then the hash function always produces the same output. So let's take an example. Suppose this is a MD5 hash. Okay, let's copy it here. Okay, now we will going to generate this same string. Let's see the hash of this string. It's same now. See, I guess it's same. So this is what we call deterministic. If the input is same, if the input is same, hash should be same. Okay. Second, it is one-way function. One-way function. One-way function means we can generate the hash value from an input, but we cannot generate an input from a value. Okay. So we suppose this is our input. We can generate a hash value from this, but we cannot generate a hash value. Sorry, we cannot generate an input from a hash value. It's wrong. We cannot do this. Okay. This is right. This is wrong. Okay, let me give you an example. Suppose now you must be thinking there are many websites which can crack the hash. Okay, yeah, there are many websites. Let me show you one. This is hash cracker. Suppose this is MD5 hash. I have copied it. Okay, it gives us this pass input from the hash value. Give so now you must be thinking I have just told you that we cannot do this. We cannot produce an input from an hash value, but this site just generated a string from our hash value. Now let me give you another example. Suppose I have this string. I copied it, pasted here. Now see, hash not found. So it can only crack the hashes of those string which the site is already known. So this pass at the rate 123, it's a very common string. Most of the users set their password as pass at the rate 123. So they know what is the hash of this pass at the 123. So they stored that hash in their database and cracked it easily. But this password, this string is not common. So they don't have the hash value of this string. So they were not able to crack this hash. So this is what we called one-way function. Okay. So the third one is collision resistance. It means that for two different input, the hash function should not create the same hash. So for example, I have just taken a example, one pass at the rate 123, it created a hash, for example, this hash. Okay. So for this string, it should not create the same hash as this pass at the rate 123. Okay, it should create a different hash for this. So this is what is collision resistant. For two different input, it should create different hash rather than a one hash. Okay, so I hope this hashing and block structure are clear. So in this lecture, we are going to study about what exactly is consensus mechanism and some consensus algorithm. So by going with the definition, it is a protocol. Okay, first of all, let me write the heading: consensus mechanism. Okay, so by going with the definition, it is a protocol or algorithm which is used to achieve an agreement among the network participants on the validity of transaction and the state of ledger. So what this means is, suppose there is a network. Okay, and in this network there are many nodes, or we can call miners. Miners, these all are miners. Okay. So how do we decide which node or which miner will add the block inside the blockchain? Okay, first of all, here's a question for you. Why miners are doing this work? Why they are adding these blocks in a blockchain? This. Why they are doing this work? Why? Of course, for reward. Okay. For adding blocks, they are getting some type of reward as cryptocurrency. So how will they decide which miner will add block, or what if the miner which is adding the block is malicious or faulty? So for this, consensus mechanism is used when all the member of a network agrees on a decision, or they achieve an agreement on the validity of transaction. Let me write the definition. Uh, so it is a, first of all, it is a protocol, or we can say algorithm, which is used to achieve an agreement. Okay, so in this, all the participants agreement on the validity of transaction. It ensures that all the nodes reach a common understanding of truth. Reach a common understanding. Okay, so let's understand the algorithm they use to apply consensus algorithm. So first algorithm is POW, which means uh, okay. So as I have explained you in the previous lecture, all the miners solve some mathematical puzzle, and the first miner who will solve this puzzle will get a chance to add a block in the blockchain. Okay, I have explained you now. Let's understand it again. Suppose this is a mempool where all the pending transactions are there. So all the miners will solve a mathematical puzzle, solve a puzzle. Okay, and the first miner who will solve this puzzle will get a chance to add a block in the blockchain. But before that, all the nodes will check the validity first, validity of block, and if the validity of block is correct, block will get added to the blockchain. Okay, block will get added. You remember na, I have explained all of this thing, what is meme poll, what is a puzzle in this, and all the things related to this I have already explained in the previous lecture. So if you haven't watched that lecture, please watch that lecture first and then come to this lecture. It's a first, let me write this. It's a kind of chain they are making. This is simple now. Okay, but proof of work, POW, have a disadvantage. It requires a lot of computing power. It has a disadvantage. What is the disadvantage? Requires a lot of computing power and energy consumption. High computing power, high energy consumption. In a network, all the miners are competing with each other to find a valid hash, but only one miner will get a chance to add a block in the blockchain. So what about the energy and resources other miners used? They are wasted. So even if this mechanism is secure, it leads to wastage of energy and resources. Okay, so to overcome this problem, another mechanism is used, which is POS, which means proof of stake. In POS, all the miners take some of their cryptocurrency and they are known as validators. So let me draw this. Suppose this is a network and there are, let's say, one. Okay, let me draw this. Three, four. Let's say there are 5 miners and they will stake some of their cryptocurrency to become a validator. Okay, what they are becoming? Validator, and they will stake. Stake means in Hindi we can call it like दाव पे लगाना. Okay, stake cryptocurrency. Okay, and they are selected probabilistically, means the validator who stake the more cryptocurrency will have a higher chance to get selected. Okay, so higher stake, higher chance of get selected. Higher stake, higher chance. Okay, so once the validator is selected, their staked cryptocurrency get locked. So if they try to do something malicious, they will lose their staked money. Okay, so once the validator is selected, the network will lock the staked currency, so that if they are malicious or try to do something fraud, they will lose their staked currency. and once they completed their block, the block is validated. The validator will then receive their reward as well as their staked money. Okay, so what will they receive? Their reward for completing the for adding the block in the blockchain, reward plus their staked currency, crypto. Okay, let's write it crypto. This method is more energy efficient than POW as it does not require vast amount of computational power. Okay, got it guys? It's more efficient now, as only one validator is doing its work. But in POW, all the miners were doing their work and only one miner is get selected. But in this, only one miner is completing his work and other miners can do their work, or they can add their or they can work on other blocks. Okay, so it is more energy efficient. So now comes the third mechanism, which is Byzantine fault tolerance. Byzantine fault tolerance. Okay, so in this method, the main goal is to ensure that the system can reach agreement on a particular state even if some system is faulty or malicious. So it ensure that the system can reach on agreement even in the presence of malicious node. So even if some node try to act malicious, the decision will be taken based on the majority. For example, there are 5 nodes, let's say 1, 2, 3, 4, 5. Okay, and let's say these 2 nodes are faulty. Let's say this one faulty and this node faulty. Okay, these 2 nodes are faulty. So they and this network is making some decision. So even if this 2 faulty nodes say no to a decision, these 3 nodes are genuine. So these 3 nodes will say yes, and the decision will be made based on the majority, which will be yes. Okay, got it guys? So that's it for this lecture. So in this lecture, we are going to see the difference between public blockchain and private blockchain. So let me write this. Public blockchain and private blockchain. So the first difference is of course of accessibility. Public blockchain is open for everyone and anyone can access it and participate in the transaction validation. So it is open for everyone. Here participants can access the network anonymously. But for the private blockchain, it restricts the access to only for authorized participants, and permission is necessary to access the blockchain. So permission from whom? Permission from the authority which is managing the blockchain is required. So only for authorized person. The other difference is that public blockchain is decentralized in nature. Decentralized, okay, where consensus is achieved through mechanism like proof of work or proof of stake, and it is maintained by a distributed network of nodes from around the world, making it decentralized. I have told you know about consensus in my previous video, so do watch this video and then watch this lecture, okay? But in private blockchain, they are often more centralized as compared to the public blockchain, as only a designated authority is controlling the whole network. So it is centralized. Centralized. Okay. So the next difference is the public blockchain is transparent in nature, as all the transaction and the data is visible to everyone on the network. Okay. So it supports transparency. But the private blockchain have privacy, as participants have more control over who can access the data and transaction. So here no transparency, or we can say privacy. The example of public blockchain is Bitcoin. Okay, it's accessible for everyone, so it is public blockchain. But for the private blockchain, the example is Hyperledger Fabric. Hyperledger Fabric. Okay. So in this lecture, we are going to see the Solidity language. Okay, so let's see what is Solidity language. So what is a Solidity language? Basically, it's a high-level programming language which is used for writing smart contracts on blockchain platforms such as Ethereum. Okay, so it's an high-level programming language which is used to write smart contracts. Okay, used to code smart contract. I have already explained you know what is smart contracts. They are self-executing contracts with the terms of agreement directly written into the code. So let's understand the syntax of smart contracts. You can use Remix ID software to do the coding, but for this lecture, I'm using its web version. Okay, so this remix ethereum.org, you can also code in this web version. So before doing the coding, you need to understand that all the code for smart contracts will be written in a file, and that file extension should be .sol. So as you can see, we have to write a smart contract inside this contract folder, and as I have told you, the extension should be .sol. Okay, so let's say you have a file where all your code is written, and let's say the file name is test. So the whole file name should be test.sol. So sol is mandatory when you are writing this solidity code. Okay, so let's understand. First of all, let me just remove this. Okay, so let's understand the syntax of solidity language. So this line, pragma solidity, this line specifies the version range of the Solidity compiler, which means that the contract is compatible with any version of the Solidity compiler greater than or equal to 0.8.2 or less than 0.9.0. Now let's see how do we declare a contract in a Solidity language. So before doing this coding, you can check this documentation of this Solidity language. Okay, here you can find all the resources and documentation of how to install the compiler, Solidity example, and this data types and all. Okay, now let's move to our coding part. So how do we declare a contract inside our in our code? Okay, so we can declare this by using this keyword contract, then this, and then we can write the name of our contract. In my case, I'm writing it as my contract, my contract, and then this brackets. So now comes to the data type. Solidity language have many data types like integer, string, boolean, etc., etc. So to include data type in our code, we can write like this: int, let's say int is this data type, and our variable name, I'm taking it as number, is equals to say 10. Okay. Oh yes. So as you can see, we are getting this error now. So to solve this error, we can put a semicolon. So if you don't use this semicolon, your code will show an error. So just like integer, we have many other data types like unsigned integer, and this, let me show you, unsigned integer, or int8 into 56. Okay, so what is unsigned integer? So unsigned integer can can be used to hold an non-negative value. Okay, let me show you. You int you int uh let's say number one is equals to 10. Okay, and what if I declare it as a negative number? It shows an error now. So this is the usage of unsigned integer. It is used to hold a positive value. And what if I just used a negative integer in int minus? Okay, so it is not showing an error. So we can use positive as well as negative value in an integer. And what is this u int8 into 56? So this 8 to 56, this value is showing how many bits the data type can store. So in this case, it can store 8 bits, and in this case it can store 256 bits. Am I clear, guys? Then we have a string data type, and we can define this data type as string. String, let's say name is equals to Panya. Okay, now why is this showing an error? Maybe you got it right. It's showing an error because we haven't put this semicolon. Okay, we can also use boolean data type. Boolean data type can hold only true values, true or false. So we can write like this: bool, let's say the variable name is last is equals to false. Okay, we also have a address data type which can store the ethereum which can store the data address of an ethereum address. Okay, so let's understand what is a function. So the function is a piece of code that performs a specific task or operation within a smart contract. So let's see how to use a function. uh, we can write it like this: function, wait, function. Okay, it gave us the snippet of an code. I'm writing again function. Let's say the name of our function is my func. Okay, and public, I will show you why what this public means. But for now, just to understand that public function can be called by anyone, including other contracts and external accounts. Okay. Oh, okay. Just remove it. I have copied a code for function. See here, this is a function. we have defined a function with this function keyword. Then this add is the function name. Public pure. Pure means that pure do not read or modify the state of the contract. Their output depends only on their inputs. Okay, this inputs 10 16. Then we have specify the return type in unsigned integer. Okay, then this code it will uh, sum the value of plus the add the value of num1 and num2 and return the sum variable. Okay, so the function of the solidity language is same as you have done in other languages. Now let's see what are state variables and local variables. So thus the data stored in a contract outside of a function are state variables. See, this is inside a contract but outside the function, so this is our state variable. But the local variable are declared within this function. So those variables which are declared inside the function are local variables. Now let's understand what are the visibility specifiers in a solidity language. There are four specifiers: public, private, internal and external. So this public I have already told you. Public can be called by anyone including other contracts and external contracts. Okay, they can be read and written by anyone. Let me explain it here. Public public means it can be called by anyone. Okay, now here another one is private. So private functions are only accessible from within the contract that declares them, and they cannot be accessed or modified by the external accounts or derived contracts. Okay, so the private function are only from accessible from within the contract. Okay, let's say this is our function, so it can only be accessed by only this function, not any other function. Okay, let's see another one, which is internal. Internal contract can only be accessible only from within the contract or derived contract. Derived means the contract inherit from the declaring contract. Okay, so it can only be accessed by within the contract or derived. Derived means, let's say you must have read the concept of inheritance in OOPS. So let's say this is our let's in Java we have this base class, and the class which got this like which is derived by this class, na base class. this is this is the derived class. This is like base class, and the class which inherited this base class is derived class. Okay, so the internal contract can only be accessed by within this contract or by derived class. Okay, now comes the external. External means that they can only be called from outside the function and can only be accessed externally, which means by external contracts or accounts or contacts. Okay, so it can only be accessible by external accounts or other contracts. Okay, so that's it for today, guys. So in this lecture we are going to talk about the life cycle of smart contract. Cycle of smart contract. So there are four phases of this life cycle. First phase is creation phase. So in this phase, parties negotiate and agrees on the contract details and goals. All the participants on the network need a digital wallet. Okay. So once the contract details are finalized, they are converted into the code. So the main task here involved is, let me summarize this all. Main tasks are negotiation of multiple parties to create this smart contract. So as I have told you that there are no central authority which can create this smart contract. There are multiple participants which sit together, negotiates, and comes to a common goal with which they can then convert it into the code of the smart contract. Okay, so the details is converted into the code. And it implement, sorry, first of all it design, then implement and validate the smart contract. Okay, so now the next phase is freezing phase. Wait, I guess spelling is wrong. Freezing phase. So in this phase, all the blockchain are validated. Just give me a minute, guys. Okay, so the next phase is freezing phase. So what happens in this phase is transaction on the blockchain are validated by the nodes, which are typically miners. So these nodes ensures the security and integrity of the blockchain network. So what happens during this phase is the smart contract and its participants become publicly visible on the blockchain ledger, and the digital asset of both the parties are locked, or we can say frozen, uh, by locking their digital wallet. Why? Because it ensures that the assets are secure and cannot be accessed or transferred until the smart contracts conditions are met. Okay, so for example, you have transferred some bitcoins to the to another party. So until the transaction is completed, your digital wallet will get frozen so that your assets inside it are secure and cannot be accessed or transferred until the smart contracts conditions are met. Okay, so the key tasks here are storing the smart contract on blockchain and freezing digital asset of involved parties. Okay, so the next phase is the execution phase. So in this phase, participating nodes read the contract and check its integrity, and then code get executed either by the smart contracts interface or by the compiler. Okay, so when one party provide a input like digital coin, the interface engine creates a transaction based on the met criteria. To ensure that the transaction fulfills the agreed upon terms specified in smart contract, or the node verifies it once again. This process is governed by the consensus mechanism, as I have told you earlier. Okay, so which ensures that all the participating nodes agrees on the validity of the transaction, and then the block get added to the blockchain. So what are the key tasks here? Again, it's evaluating evaluating the conditions which is specified by smart contract and executing the statement triggered by those condition. Okay, so what this line means, as I have already told you earlier, suppose this is a condition X, this is a condition Y. So what will happen when this condition trigger is, this statement will execute, and if Y condition trigger, this statement will execute. Okay, so this line means executing the statement triggered by those condition. Okay, so here comes the last phase. Last phase is uh, last phase is finalized phase. Okay, so after the contract has been successfully executed, the new states of all the parties are updated. This means that any change or transfer of any digital assets have been completed. So during this phase, the updated state or information and resulting transaction are recorded on the distributed ledger. The consensus mechanism verifies that the asset transferred by the first party have been successfully received by the receiving party. Okay, so we can say that here all the transaction is completed. So the key tasks are updating the state information, means updating their balances, their new balance, everything, and allocating digital asset according to contract, and the last is the digital asset which was frozen in the second phase are now unfrozen and transferred to the receiving party. Okay, so means frozen asset is unfrozen and received by the receiving party. So this means the transaction is now completed. Okay, I hope you understood this lecture. In this lecture, we are basically going to talk about Ethereum gas. So as I have already told you, Ethereum is same like Bitcoin. It is decentralized open source blockchain platform that enable the creation and execution of smart contracts and dApps. So now the question is, what is Ethereum gas? So as you already know, for running a vehicle, we need a gasoline, right? So same in this case, for executing an operation or transaction on the Ethereum blockchain, we need a gas. Okay, so let's say this is user A, this is user B. So for creating a transaction from A to B, this is A, this is B. So for the transaction from A to B, we need gas. Okay, gas to perform this transaction. So it is a unit of measure for calculating the computational work. Okay, so what is a gas? Unit of measure for calculating the computational work. Okay. Every operation consumes a certain amount of gas, and users must pay for this gas using Ether, which is the native cryptocurrency of Ethereum blockchain. Okay, so Ether is the native crypto of Ethereum blockchain. Okay, so before learning about the different things about Ethereum gas, let's first understand the relation between Gawai and Ether. Okay, so Gawai is also a unit of measurement of gas price, and the basic relation between these two is this. Okay, so Ether is greater than Gawai. Okay, uh, we can say that 1 Gawai is equal to 0. Ether. Okay, am I clear, guys? 1 Gawai is equal to 0.00000001 Ether. Okay, so now let's understand the basic things related to Ethereum gas. So first one is gas limit. Gas limit. So it means the maximum amount of gas that the sender is willing to pay for the transaction. Okay, I will give you an example. For first of all, I am writing the definition. So it means maximum amount of gas sender is willing to pay. Okay, so suppose the gas limit set by the sender is 50,000. Okay, let's say gas limit is this. Okay, it's just an example. 50,000. Okay, and for the transaction the gas required is 21,000. So it will used okay, wait. So it will use this 21,000 from this 50,000 and refund the remaining amount to the user. Okay, so the remaining amount will be just calculated 50, minus this amount 50,000 minus 21,000, and what will be the remaining amount, it will get refunded into the users account. Okay, so but what if the gas limit is, let's say it's another scenario we are taking. Just, okay. So gas limit is 20,000 and the gas required is again 21. Okay, 21 units. So what will happen in this case? Any idea? No. So in this transaction, uh, in this case, transaction won't happen, and those 20,000 will also be used to perform the transaction. But ultimately, the transaction won't be happen. Okay. So your so in this case, your 20,000 will get wasted. Okay. So now comes the concept of gas price. Gas price. So gas price is like just wait, let me write the definition first. So gas prices cost per unit of gas in terms of either. Okay, so it's an cost per unit of gas in terms of ether, and the higher the gas price, higher the chance that miners will prioritize your operation than any other operation, as it is more profitable to include in a block. So what I'm saying is, gas prices uh, high is equals to gas, sorry, uh, high priority. Okay, so for example, let's say this is transaction A. Suppose this is transaction A, and it has a gas price of 20 gawai. Okay, which means 0.0000. Okay, something like this. Okay, and now another transaction B, it have gas price as 20 gawai, which means 0.00001 ether. Okay, so between these two transaction, which will have the high priority? Of course, of transaction A, because it has more gas price. Okay, so this is the main concept of gas price, that higher the gas price, higher the priority. Now comes the concept of transaction cost. So it is calculated by multiplying the gas limit by gas price. Okay, so this represents the total amount of ether the sender must pay to execute the transaction successfully. Okay, so total amount of ether sender must pay execute transaction. Okay, so let's take an example. Let's say A have a there's a person A, and it have a gas limit as 21 units. Okay, and the gas price is 20 gawai. So the transaction cost here will be 21,000 multiplied by 20 gawai, and which will be equals to, it will be 42 gawai, and in terms of either it will be 0.00042 either. Okay, so now let's say the actual gas used is 20,000. Okay, 20,000. The gas limit was set at 21,000, but the actual gas used here is 20,000. So here the gas which will get refunded will be calculated as 21,000 minus 20,000, 21,000, 21,000 and 20,000. Let me write it in a bracket so we can use BODMAS method. Okay, into 20 gawai, and which will be and after calculation the answer will be something like this. Okay, so so the person A will receive this much refund of the gas. Okay, so now comes the concept of gas fees. So it is the fees paid by the user for the computational resources consumed during the transaction execution. Okay, so what it is, paid by users for computational resources consumed during transaction. Okay, and it is calculated by multiplying amount of gas used by an operation by price per unit gas. So that's it for today, guys. I hope you enjoyed this lecture. So till now we have seen what is smart contract and how does it work. So now let's see what is the advantages and disadvantages of smart contracts, because not everything we are using is 100% advantageous. Okay, everything has its disadvantages too. So let's first understand what are the advantages of a smart contract. So advantages. So first advantage is its autonomy. Okay, so it means that smart contracts don't need any third party to execute the rules. Okay, so earlier if there's a transaction between two parties, let's say this is A, this is B, and there is a transaction between these two parties. Okay, so it go through a lot of paperwork, but now with the help of smart contracts we don't need any third party. They can self execute without any agent or broker. Okay, so what it means is autonomy means no third parties. Okay, next advantage is transparency. Transparency. So as I have already told you earlier, there are multiple nodes on a network and every node have a copy of the information. Okay, so in this way every node can see or verify the information. It logs all the history and copy the information to the every node. So do I need to draw the diagram again for this? I have already drawn it multiple times. Okay, let me draw it again for you. So this is node 1, this is node 2, this is node 2. Okay, let's say there are only 3 nodes in this, and this is node 3. So every node in a network will have the same copy of information. Okay, let's say it will all have this information, and it will have the copy of this information, and it will also have the copy of this information. Means every node will have the same information, copy of the same information. Okay, so this is what we call transparency. Every node will have a copy of information, and plus it logs all the info. Okay, so next one is cost saving. Cost saving. So smart contracts eliminates the need of third party, as I have told you earlier. Thus users no longer need to pay fees to the third party, thus saving their cost. Okay, so see, this is A, this is B, and this is some third party. Okay, so to do the transaction it will first go to this third party, and third party will give the transaction to the B. Okay, A, B, and let's say this is third party. I'm denoting as a TP. Okay, third party. So this is what the traditional method was, but in the smart contracts, no third party is used. Okay, so the thus it eliminates the cost of this third party. Eliminate the cost of third party. Am I clear, guys? So the next one is security. So smart contracts uses cryptographic techniques and blockchain technology to ensure the integrity and confidentiality of a transaction. So once the smart contract is deployed, it cannot be altered without consensus from all nodes. Okay, so it uses cryptographic cryptographic techniques, plus it uses blockchain technology to ensure the integrity and confidentiality of a transaction. Okay, now let's come to the disadvantages of a smart contract. Disadvantages. So the first disadvantage is it's complex. Okay, it is complex. It requires a deep understanding of blockchain technology and solidity programming language. Writing a bug free and secure code is challenging. Okay, so what I have told you, deep understanding of blockchain and solidity, as smart contracts are written in the solidity programming language. Okay, and writing a bug free and secure code is really very challenging. Next one is it is difficult to change, or we can say irreversibility. So smart contracts are immutable. It is almost impossible to update the current contracts, and in case of a critical flaw, the contract may need to be replaced with a new version. And if replacing it with a new version, it can cause a disruption to any ongoing transaction which rely on current contract. Okay, it can disrupt the business operation and user experience. So it is almost impossible to update the current contract, and in case if it is very critical, so while changing this whole smart contracts, it may disrupt the ongoing transaction. Okay, so it is immutable means difficult to change, and it can disrupt operation while changing smart contract. Okay, guys, now the third disadvantage is scalability. So during high network congestion, the transaction become really very slow, and it can trigger more cost than you expected as expected. Okay, as smart contracts copy every transaction to all nodes in a network, so it takes time to do this task. Okay, so in case of high network congestion, if there is a um, smart contract copies every information to every node now, so it takes really very time, and it can trigger more cost than you have expected. Okay, so uh, transaction are slow and trigger more cost in case of network congestion. Okay, so the last disadvantage is external data dependency. So smart contracts often rely on external data sources such as Oracle. but it introduces potential security risks. Okay, we will be talking about this Oracle vulnerabilities in the upcoming lecture. So, what is external data dependency? Uses external data sources like Oracle, okay, Oracle, which may have potential vulnerability. Okay, let me write here Poten- potential vulner- vulnerability. Okay, so that's it for today, guys. So in this lecture, let's see what are the blockchain network attacks. Blockchain network attacks. Okay, so blockchain network attacks refers to a malicious activities which aims to disrupt the transaction or compromise the security or integrity of a blockchain network. Okay, so what it is? First of all, it's a malicious activity which disrupt the transaction or compromise the or security or integrity of a transaction. Okay, so the first attack we are going to see is 51% attack. Okay, 51% attack. So in this attack, attacker gain control of the majority of hashing power in a proof of work blockchain network, which allows them to manipulate the transaction. Okay, so what it is, in this, attacker gains majority of hashing power. So hashing power means computational power. Okay, so the attacker on this half of this computational power. So 51% attacks lead to double spend problem. Okay, it leads to double spend problem means it's due to 51% attack, double spend problem happens. It's an impact of 51% attack. Okay, so let's take an example to understand the double spend attack. Okay, so suppose, let's say this is A and this is B. A and B. Okay, so let's say A sends some Bitcoin to the uh, Bitcoin to B. Let's say it sends one Bitcoin. Okay. Now this whole transaction is broadcasted to the Bitcoin network. Now there is an attacker who controls more than 51% of the hashing power, as I have told you above, means computational power. Okay, so what the attacker did is he starts mining a separate chain of blocks that includes a fraud transaction in which A sends the same Bitcoin which he was transferring to B to himself. What this means is, let's say this is a blockchain, first block and second block. Okay, let's say there are two blocks in this blockchain and it has some transactions information. Okay, now what will happen is, let me do this first, then I will tell you. Okay, so suppose this is a blockchain and now uh, from this block I don't know if my cursor is visible to you or not. Okay, let me draw this from this block. Okay, so from this block, this there starts separate block from this block. Okay, so this is chain A, this is chain B, and let's say this chain A, let's call this chain A. Okay, this chain A, and in this chain A, there's a this blocks contains a transaction from A to B, as I have told you. This A to B transaction of 1 Bitcoin. Okay, and then there is an another fraudulent fraudulent transaction, means not valid transaction, in which what attacker did is it means it transferred the same Bitcoin which A was transferring to B to A itself. Okay, to A itself. So there, so the valid one was which A was transferring to B, but attacker creates another fraud transaction in which A is transferring that same Bitcoin to A itself. Okay, so let's say in this block, in these blocks, it contains this valid one which A was sending 1 Bitcoin to B, and in this chain it contains invalid, means A is transferring that same Bitcoin to itself. Okay, so now there are two blockchain in which one include this transaction from A to B which was legitimate, and other chain which contains the fraud transaction which A was sending the same Bitcoin to himself. Okay, so as the attacker have more than half of the hashing power, okay, attacker has 51% of that hashing power now, so attacker will mine other block faster. Okay, means attacker will start mining all other blocks faster. Let's say this block, this block, this is attacker, this is the block which attacker is mining. Okay, so let's say attacker mined 4 blocks. Okay, let's say attacker mine 4 blocks. Okay, so there is a rule in the blockchain which says that whichever chain is the longest will be considered as a valid chain. Okay, so what I have told you there, that whichever the chain is valid will be considered as a valid chain. Okay, so sorry, whichever chain is the longest will be considered as this valid chain. Okay, so as the attacker will mine other blocks faster, which will create the long chain of this fraud transaction. Okay, as attacker have 51% of this hashing power na, so it will mine blocks faster than other miners. Okay, and so what will happen is this B chain will be considered as valid, and the blocks which is the in which is in the shorter chain will be discarded. Okay, or will be treated as invalid. Okay, so in this case what will happen, this fraud transaction will be considered as valid transaction, and this real transaction which was originally valid. Okay, so this one, let me draw this. So this chain will be considered as invalid. Okay, so what will happen in this case, be the this transaction which A was sending 1 Bitcoin to B, so 1 Bitcoin, B will not receive this Bitcoin, instead A will receive that same Bitcoin again. Okay, so this is called the double attack. Let me summarize this attack again. Suppose A is sending a 1 Bitcoin to B, so what attacker will do, attacker will create a fraud transaction in which A is sending that same Bitcoin to itself. Okay, and as attacker have 51% of that hashing power, attacker will create its long chain, and the valid chain which contain that valid transaction will remain shorter. Okay, so chain this valid chain will be discarded, and this attacker chain will be considered as valid. And what will be the impact of this invalid chain have that invalid transaction, and in this invalid transaction will be treated as the valid transaction, and so B will not receive any Bitcoin. Instead, A will receive that Bitcoin. Okay, so this was the whole scenario of the double spending attack. Okay, let me just remove all this mess. Okay, I hope you understood this double attack. So another impact of this 51% attack is transaction reversal, where the transaction which was previously confirmed is invalidated or reversed. Okay, and another impact could be reputational damage. So I'm writing this impact here. Impact of 51%. First of all, double spending, or another one is transaction reversal and reputational damage. Guys, if you don't understand this double spending attack, na, please watch this video again, because this attack is very important. Okay, now let's see another attack, which is routing attack. Routing attack. Okay, so in this attack, attackers disrupt the connectivity between nodes by partition the network between two or more disjoint component. Okay, so suppose this is a network. So what attacker did is partition this network, so it becomes the two disjoint network. Okay, it becomes two disjoint network. So in this way, attacker blocks the communication between nodes in a certain chain and the one that are outside of it. Okay, this way attacker creates a parallel blockchain, and when the attack is over, all the block in the smaller chain are discarded. Okay, so as I have told you, in this double attack, na, the smaller chain one will be discarded. All the blocks in the smaller chain will be discarded. So same as in this case, the smaller networks, the smaller chain are in this way are discarded. Let's say this is the smaller chain, so all the transaction in this network is discarded, and this will be treated as valid. Okay. I don't know what mess I have created in this. Let me write this so you understand it better later on. So what happened in this? Attacker disrupt the connectivity by partition the network. Okay. It create a disjoint component, and the smaller chain is discarded, means smaller sorry all transaction in smaller chain is discarded. Okay, so next attack is front running attack. Front running attack. So according to its definition, it means a malicious practice where attacker exploits advanced knowledge of pending transaction to gain an unfair advantage over other participants. Okay, so I know you didn't understand anything, so let's take an example to understand it better. So suppose A, again this A and B, A and B. No, sorry, not A and B this time. Only A. Okay, so suppose this is A. So A wants to swap one Ether for 100 token for the newly listed cryptocurrency. Okay. So what A want to do? One Ether for 100 tokens. Okay. One Ether for 100 token. So attacker who was monitoring this transaction pool, see this transaction and quickly submits its own transaction at higher transaction fees. Okay. So what attacker did was, attacker created the same transaction. Let's say this is attacker, so it created a same transaction but with the higher transaction rate. So what will happen, let's say this is the uh, block of this A, which contains the transaction of A, and this is the block of attacker. So what will happen, this attacker blocks will be prioritized over this A's block. Okay, why? Because it have higher transaction rate. So how will this blockchain looks? This, wait, what is this happening? So what will happen? Let's remove it. Okay. So what will happen? This attacker block will be prioritized over A block, and attacker's transaction will be validated first. Okay. So in this way, attacker purchases this token before A, before person A, which creates a more expensive price for person A to trade. Okay, so this is what we call front running attack, in which attacker prioritized its own transaction before the person A's transaction, and which creates a problem for person A. Okay, so let me write this definition. It's a malicious activity where attacker exploits advanced knowledge of pending transaction to gain an unfair advantage. Okay, now this definition is clear to you, I guess. I have already given you the example, so this definition will be clear to you. Okay, so now comes the transaction privacy leakage. Transaction privacy leakage. So in blockchain network, every transaction is transparent and open. But sometimes transaction may contain some sensitive information about their issuers. It can contain metadata that can provide the nature of transaction, like timing, frequency, size, etc. etc. Okay. Or sometimes because of the programming error in a smart contract, it can leak the sensitive information. So what does transaction privacy leakage is? It can leak metadata of transaction, or due to the error in programming language in the smart contract, it can leak sensitive information too. Okay, it is same as like you have learned in bug bounty, information disclosure bug. Okay, so that's it for today, guys. So let's understand the vulnerability related to consensus mechanism. Okay, so the first one we are looking from POW, which is proof of work. Proof of work. Okay, so the first vulnerability from proof of work is 51% attack. So I have already told you what this attack in previous lecture. The attackers gain majority control or control of the network's hash rate. Okay. So 51% attack. You already know what it is. So I don't think I need to explain this in this lecture. Okay. So the second attack here is selfish mining. Selfish mining. So in this attack, a selfish miner holds all the solved block from the network instead of adding it to the blockchain. So in this way, selfish miners can gain a competitive advantage over other miners, and this can lead to centralization risk as these selfish miners accumulate more power and influence. So as always, we are going to see an example related to this vulnerability so that you better understand this vulnerability. Okay. So uh, suppose there's an attacker A. This is an attacker A. Okay, no, we always draw attacker in circle. So this is an attacker A, and this attacker A is a selfish miner. Okay. So if I say attacker A, so just understand this is selfish miner. Okay. So what is what this minor A will do? It will solve the mathematical puzzle, and instead of adding it to blockchain, it will hold this particular block. Okay. So what happens during normal cases? This minor wait. So this miner will solve a mathematical puzzle, and when this uh, his block will validate, it will get added to the blockchain. Okay. But in this case, this selfish miner won't add that blockchain a block into that blockchain. Okay. This miner will hold that block, okay. Suppose this is a block, and this miner will not add this block into the blockchain. So now again he will repeat the same process. So what will happen? He will again solve a mathematical puzzle, and instead of adding it to blockchain, he will just hold it for himself. Okay. So it creates a hidden chain of block that is not visible to rest of the network. Let me just draw this line to create a chain. Okay, I know guys, this is a bit theoretical, but don't worry, we will do all the practicals in the upcoming lectures. Okay. So now again he repeat the whole process and create a hidden chain that is not visible to the rest of the network. Okay. So when the selfish miner discovers this long chain, he will reveal his secret chain and bind a secret chain into the network. So by doing so, he will invalidate work done by other miners who are working on the short chain. Okay. So first of all, he will create this long chain of blocks. And let's say other miners was also doing also solving these blocks. So what other miners was doing? Suppose these blocks, other was working on this chain. So what will happen? As I told you in the previous lecture, the longest chain is considered valid, and the short chain will be discarded. So again, what happened in this case? This selfish miner's long chain will be considered as valid. I don't know, my cursor is visible to you not or not. So this will considered as valid chain, and in this way attackers steal the block rewards and transaction fee from other miners. So this will be discarded, and in this way attacker steals all the rewards of other miners. Okay. So this is what we called a selfish miner. So the next attack we are seeing is double spending attack. Double spending attack. So as I have already told you in previous lecture how this attack was performed by linking it with 51% attack. Okay, but it is also possible to do this attack without 51% attack. So I guess you already know what is double spend attack. I have already explained this attack in previous lecture, so I won't be explaining the same thing in this lecture also. Okay, so I think uh, every vulnerability of POW is clear to you. So now let's come to POS vulnerability, which means proof of stake. Okay, so the first one is the first vulnerability is nothing at stake. Okay, so here, as you know, in POS, power proof of stake, the miner is chosen based upon the stake he's giving. Okay, so the higher the stake, the higher the stake, the higher the chance of getting selected for chance of be a miner. Okay, so wait, just let me, where is stake? Okay, so as you already know, higher the uh, stake, higher the chance of being a miner. Okay, so but the validator of POS, means proof of stake, does not stake anything, means they have nothing to lose. Only the miners stake something, stakes some cryptocurrency to be a miner, but the validator here does not stake anything. Okay, anything, means they have nothing to lose. Unlike POW, where miners invest their resources such as computational power, their electricity, POS validators do not invest anything. So this lack of resource commitment leads to network forks. Okay, so let's see with an example. Suppose in a blockchain, everything is going smoothly. Okay, everything is going smoothly. This is one block, this is another block. Okay, let's say they have smoothly mined these two blocks. So, what will happen now? But due to some disagreement arise within the network, multiple chains are created. Okay, so let's say these multiple chains are now created. I think I should draw all this drawing before starting this lecture. Because of this drawing now, this lecture takes a lot of time. Okay. So this created a multiple chain, and so in this, as I have already told you, validators have nothing to lose. Okay. So they see this as an opportunity and they start supporting this multiple chains, and this could lead to the confusion and potential disruption in transaction process. Okay, so uh, uh, validators start supporting this multiple chains. Okay, some are mining on this chain, some are mining on that chain. Okay, so let's say I don't destroying now. So now attacker, what will happen? Attacker will see this as an opportunity and he can perform double spending attacks or reorganization or any other attacks. Okay, so this is the whole scenario. Yeah, this is the whole scenario of nothing to stake, where due to some disagreement, uh, multiple chains are created and attacker sees this as an opportunity and he can perform double spending attacks or any kind of attack. Okay, so next attack is long range attack. Long range attack. Okay, So it's a little bit same as selfish mining attack, where an attacker with a significant amount of cryptocurrency create a long and valid chain in secret and replace the current chain, which leads to rollback of transaction. Okay, so it's like just like selfish mining attack, where a attacker with a lot of cryptocurrency creates a long chain. Okay, so suppose this is a blog and he secretly worked on this blogs, and after some times he releases log chain, which uh, which discard the original shorter chain, and this long chain will be treated as this valid chain. Okay, so it's same as this selfish mining, but there's some difference. In selfish mining, miners need to have a good hash rate, means they need to have good computational power, but in long chain long range attack, it is chosen based upon the amount of cryptocurrency they hold. Okay, so in short, in POW, attackers need to have a high computational power, but in POS they need to have a good cryptocurrency. Okay, means a significant amount of cryptocurrency. Okay, so let's see the next attack, which is stake grinding. I hope guys every attack is clear to you. I'm doing a lot of efforts to uh, on this lectures. Okay, so let's see the next attack, which is stake grinding. So in this attack, attackers attempt to manipulate the process of block creation to their advantage. Okay, so let's suppose there's an attacker A. Let me draw this attacker A. So in this is attacker A, and attacker conducts an in-depth research analysis on how the miners are selected. Okay, so he what he did is research how miners are selected. Okay, and after doing a in-depth research, he identifies a flaw in the algorithm. Okay, so he got a flaw. Now, attacker manipulates his stake in such a way, like by manipulating a specific parameter or timing, that it increases his chance of being selected to create two blocks. Okay, so in simple words, if I say, suppose uh, there's a flow in this POS system that let's say there are uh, 5 minus 8. So there are 5 minus 1, 2, 3, 4, 5. Okay, so let's say in POS there's a flow, like if that um, the miner which will come on like on a specific time, so that miner will be selected as miner. Okay, so this attacker A identifies this flow, and uh, he manipulate his stake in such a way that it came as this as on this specific time only. Okay, so it increases his chance. We can't say that he will he will become a minor only, but like ऐसा कोई वो नहीं है कि माइनर वो ही बनेगा, बट इट इंक्रीजेस हिज चांसेस. ओके, it's not 100% sure that he will become a minor, but it will increase his chance. Okay, so this is what we called and stake grinding attack. Okay, so that's it for today. So in this lecture we are going to see a cyber attack. Okay, cyber attack. So in this attack, attacker creates a single malicious multiple fake identities or nodes to gain control over a network. And with these fake identities, attacker can manipulate the network's behavior, disrupt its operation, or gain unfair advantage. Okay, so what does attacker do? Attacker creates multiple fake identities. Okay, and with these identities he gains control over the network, and with this attacker can disrupt the operation or gain unfair advantage. So it's very similar when you create a multiple fake accounts on social media and comment on your own photos which is posted on your main account with those fake accounts. Okay, so in this way you increased your like and comments on your photos. So what are the impact of this attack? So first one is node influence. Okay, so here I am writing the impact, which is node influence. So an attacker creates many fake nodes on the network and increase their influence on the consensus mechanism. Okay, so let's say we have in this network we have 5 nodes. This is 1 node, this is 2 node, this is 3, 4, 5, and in this node, okay, so these are the 5 nodes, and these 3 nodes are attackers fake identities. Okay, so what happened here is in this whole network, this attacker controls this whole network and the consensus mechanism. Okay, so so whatever decision will be made in this consensus mechanism, the attacker will be the one who will influence those decision. Okay, and then the next impact can be voting manipulation. So like I have explained you in DAO that every node have a vote and decision is taken on based on what majority is saying. So in this way, this attack can change the decision making by creating fake accounts to manipulate the votes. Okay, and another impact is 51% attack. So I have already explained you in this attack, the attacker gained 51 means half of the majority of the computational power of the network. Okay, so now let's come to another attack, which is spam transaction. So in this attack, attacker creates and propagate large volume of low value transaction on blockchain. So this transaction serves no purposes and it is used to disrupt the network's operation. So what it means is, like suppose this is A, this is B, and they both are malicious. Okay, they both are attacker, so they will create a low transaction of large volume. Okay, let's say they created 100 of transaction with 100 or 1000 transaction with just low value, say 1 Bitcoin, and etc etc. Okay, you can I hope you get that example. So this can create a DOS in the network. Okay, so the here impact here are the network congestion, network congestion. So in network congestion, the valid transaction can be delayed and the transaction fees can be increased. Okay, another example could be economic incentive. So here miners can act as an attacker and they spam meaningless transaction so that they can mine the blocks and earn the extra reward. Okay, so as you all know, in POW, proof of work, the miners mine the blocks, and for mining that block they will get rewards for that. Okay, so here miners can spam hundred or thousands of high volume of low transaction, and with this they have more blocks to mine and they can earn extra reward. Okay, and another impact could be DOS, where the whole network can become unavailable to the valid user. Okay, so that's it for today. So in this lecture we are going to see what is the oracle manipulation, but before that let's understand what is oracle. So let's see what is oracle. So oracle is a third party which serves as a bridge between blockchain network and the external world by providing the data to the smart contract. Okay, so first of all I'm writing this definition. It's a third party. Okay, and it provide data to smart contract. Okay, and you can say it serves as a bridge between blockchain network and external world. Okay, so let's take an example. Suppose this is a smart contract. This is a smart contract, and it need weather in data to perform its work. Okay, and suppose this is a weather data. Okay, this is a contract smart contract, and this is weather data. Okay, so to get this, okay, so to get this weather data, a smart contract use oracle, which will provide the weather data to smart contract. Okay, so what will smart contract do? It will just use oracle, which is a third party, to get this weather data. Okay, so oracle will contact this smart contract will contact oracle. Oracle will get this weather data, and then this oracle will provide this weather data to smart contract. Okay, so here comes our main topic. What is oracle manipulation? Oracle manipulation. Okay, so it means tampering or influencing the data provided by oracle to a smart contract, and with this it will affect the outcome of smart contract execution. So what this is, first of all, it means tampering the data uh, provided by oracle. Okay, and what will happen if if smart contract will get the tempered data? It will affect the outcome of smart contract execution. Okay, so what I'm saying here is, okay, wait, first of all let's understand the first technique, which is data tampering. Okay, so data tampering means attackers modify the data which is coming from oracle, as I have explained you here. This as I have told you, this tampering the data by oracle. So this means this is the technique which is data tampering. Okay, so in this way the data which will be received by the smart contract will be manipulated data or falsified data by the attacker. Okay, uh, it's same, I guess. Tampering the data provided by oracle and in this way a smart contract will receive the tempered data. Okay, so for example, let's say uh, this is a person A. Okay, this is a person A, and person A bet on a cricket team. Let's call it XYZ. Okay, so wait, I'm writing this first, person A, so you won't get confused. So what will happen? Smart contract will fetch the result of the cricket match from Oracle. Okay, so suppose this is again smart contract. This is Oracle. Smart contract, and this is our Oracle. So what will happen? This smart contract will fetch the data from Oracle. Okay, a smart contract will say, Oracle, please give me the result of cricket match. Okay, but here the attacker will modify the result of the match. Okay, so suppose this data is coming from Oracle, and in between this attacker manipulated the data. Okay, attacker manipulated the data, and as a result this smart contract will receive this manipulated data. Okay, so what will happen? The attacker will make it appear that team ABC won instead of team XYZ. Okay, and in that way falsified data will go to smart contract, and ultimately person A will lose all its money even though team XYZ won. Okay, so this is data tampering. Another technique could be attacker targets the oracle itself and exploit the vulnerability in its infrastructure. Okay, so attacker will target oracle itself and exploit its vulnerability. Okay, and another attack could be on its data source. So what will happen in this case? uh, this attack is called data feed manipulation. So in this, attacker can manipulate the data source used by the oracle to fetch the information, means attacking the external system or API that provide the data to oracle. Okay, let's say oracle, this is oracle. Okay, sorry, this is oracle, and to fetch some data oracle is using some its API. Okay, let's say this is API. So in this case, attacker manipulate this API. Okay, and what will happen? Oracle will receive the falsified information. Means attacker um, manipulate this external system that provide the data to Oracle, and what will happen then? Oracle will give this falsify falsify information to the smart contract. Okay, so here I have explained you all the three techniques. Let's see the impact. I guess impact is really very simple. Impact, first impact is financial loss. As I have explained you in this above example, what will happen in this case? This person A ultimately lost its money because of this vulnerability. Okay, another can be smart contract exploit. Smart contracts exploit as by wait, exploit as by manipulating the data provided to smart contracts. Attacker can exploit the vulnerability in the contract logic. Okay, and another can be reputational damage. Any attacker can damage the reputation of the organization. So that's it for today. So in today's lecture, we are going to discuss about denial of service attack, or in short, DOS attack. Denial of service, DOS. So in blockchain technology, this DOS attack tries to disrupt the normal operation of a blockchain network by sending high volume traffic or transaction, which causes network congestion, delay, or temporary shutdown. So if I explain you with the help of a diagram, let's say this is an attacker and this is a blockchain technology. Okay, attacker, blockchain technology. Okay, so what attacker do? Attacker sends high volume of traffic to this blockchain technology. It could be a high volume of block or transaction, which will ultimately disrupt this whole blockchain technology. And ultimately, what will happen? This blockchain technology will not respond to the legitimate transaction, or we can say this blockchain technology will get shut down. Okay, so there are many common types of DOS attack. First is transaction spam. I have already explained you this in previous lecture. Attacker floods the network with large number of low value transaction, which consumes bandwidth and resource, causing congestion. Okay, I'm not going to explain all of this thing again. So if you haven't watched my previous lecture, do watch this to understand this transaction spam. So another type of DOS attack is can be achieved by block spam. So this is another type of DOS attack where attacker creates and propagate large number of invalid or empty block, which consumes storage space, bandwidth, and computational resources. Okay, so what happened in this case? Just like this in transaction spam, we send low volume transaction na? So in this block spam we send high volume blocks, which are mainly of no use. Okay, they have no transaction, no data in it, and it is used to just disrupt this whole blockchain technology, which causes ultimately this DOS attack. Okay, another technique can be cyber attack. I have already explained you this cyber attack, where attacker creates a large number of fake nodes, and this fake nodes floods the network with fake transaction and request, which again lead to DOS attack. Okay, and another technique can be eclipse attack. So this is a new attack for you, I guess. So in eclipse attack, a targeted node get isolated because of these malicious nodes. Okay, so let me draw the diagram. So what happened in this attack? Suppose this is a target node. Okay, let me denote it as target node means TN means target node. Okay, so in this attack, attacker surrounds this targeted node with a ring of malicious node. Okay, let's say something like this. it creates a ring. Attacker surrounds this targeted node with a ring of malicious nodes, and this arrangement allows the attacker to control the flow of information to and from the targeted node. So, malicious node intercept and filter the incoming and outgoing communication of the targeted node. Okay, so this uh, suppose there is another node. Let's call it as honest node. So what will happen if this uh, targeted node will send something to this honest node? It will go between this. We call it as a malicious node. Okay, so malicious node intercept this communication, and it controls this incoming flow and this outgoing flow of information. Okay, so it block or delay the transmission of valid blocks, transactions, and messages between targeted node and honest node. Okay, so it blocks this communication. Na? First, let me draw here. So suppose this is targeted node, this is malicious node, and this is another honest node. So first, this information will go to a malicious node, and this malicious node will send this information to this another node. Okay, another honest node. So instead of sending directly to honest node, it first go to this malicious node, then a malicious node send it to target node, another honest node. Okay, so it malicious this malicious node can just, let me use this. So this malicious node can just manipulate the information or drop this request and do anything with it. Okay, so again, as I've told you, this malicious node intercept and filter the incoming and outgoing communication of the targeted node, and block or delay the transmission of valid blocks, transaction, and communication. Okay, and this disrupt the ability of this target node. Okay, it disrupt this ability to of this target node to participate in consensus mechanism and synchronization with the rest of the network, which leads to exhaustion, and which ultimately leads to DOS. Okay, I hope you understand this Eclipse attack. This targeted node uh, will get isolated because of the all these malicious nodes, and all the information from this to and from this targeted node will first go to this malicious node, and this malicious node can just block this request, or drop the request, do anything with this request, or maybe manipulate this request and then send it to the honest node. Okay, so what is the impact of DOS attack? So first one is disruption of service. Second one is economic loss. Economic loss. Okay. How economic loss? Suppose there's a transaction which needs to be done urgently, but because of this DOS attack, the user have to pay higher transaction fees. So to get this done uh, transaction done fast, and this transaction fee is higher than in normal condition. Okay, so what I mean is, suppose this transaction needs to be done urgently, needs to be added in the blockchain urgently. So for this, the user have to pay higher transaction fees than they pay in the normal conditions. Okay, because of this DOS attack. And last one is loss of functionality because of this DOS attack. There are many losses of functionality. User are unable to access some function of the blockchain technology. Okay, so that's it for this lecture.